This is a way to make an extremely steep wave where you produce a carefully controlled group of frequencies which build up and give you a breaker just when they hit the duck. And it duly capsizes and recovers. That really is an extreme test. We reckon to have run about 500,000 years worth of 50-year waves. Here it comes again in slow motion this time. Maximum force on the duck occurs about now, sometimes 20 seconds after the passage of the big break. So we think that wave height is rather misleading. We should really think more about the horizontal velocities and accelerations of the wave. This is a measurement of the force record instantaneously going through the freak. And this is even slower motion. Concrete's a bit too strong for the duck body. We'd like to average properties of concrete and polystyrene. Now this is a duck moving on a fixed mounting, very rigidly held, with a very long wave, a wave about 25 duck diameters in length. But now we're reducing the stiffness of the mounting, and whereas before we had 30% efficiency, now the mounting's moving a lot more and the efficiency's climbing up. This experiment is suggested to us by David Evans, and he predicted very clearly what would happen. What we're doing is we're creating a wave behind, deliberately, which is the inverse of the wave that's sneaking underneath the duck. That's an artist's impression of the power takeoff mechanism. The artist's idea of the bearing is completely wrong, but the insides are about what we were planning. We've got an evacuated cylinder with the 4 gyros in, and the nodding motion of the duck makes the gyros precess, and you can do work that way without having any external reaction. We've got an analog computer simulation of the gyros, and we can dial up inertia and various dynamic features. Quite a lot of knobs to adjust there. And they're quite happy with gyros inside. The flywheels of the gyros can use to store energy for perhaps half an hour. Another series of models close up, including the Evans cylinder at bottom left, the very first one that was tested, confirming the predictions of the very high efficiency it can do. And at the bottom left now is the duck that we used in the wide tank experiments with a compliant mounting inside.